Welcome to today's math lesson on writing non-proportional equations from verbal descriptions. Our do now is to complete the graph using the ordered pairs provided. So we have 0, 10, 1, 8, 2, 6, 3, 4, and 4, 2. So our first step is to label our x and y axis. So our x is going to be our horizontal line, and our y is going to be that vertical axis line. And from here, I'm going to look at the range of our x values for our points, so that's 0 to 4. So I can always represent each unit or each box to be 1, but I can also have the value of each box be half, so that every 2 boxes, it's going to represent a value of 1. And I'm going to do that for this case, so my graph isn't squished together. It's a little more stretched out, so every 2 boxes is 1 unit. And then the range in our y values is from 2 to 10. So I'm just going to say that each box on our y-axis is representative of 1. So if this is 0, this would be 1, this would be 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. Okay, starting with 0, 10, which is our y-intercept, I'm going to start at the origin, and I'm not moving any units to the right on our x-axis, but I'm moving 10 units up on our y-axis, since each box is representative of 1. Then, starting at our origin, I have to go to 1, 8. So on our x-axis, I'm going to move 2 units over, which is the value of 1, and then 8 units up. Then for 2, 6, I'm going to start at the origin, move to the value of 2 on our x-axis, and up to the value of 6 on our y-axis. For 3, 4, I'm starting at our origin. I'm moving to the value of 3 on our x-axis and 4 units up on our y-axis. And lastly, we have 4, 2, so starting at our origin, moving over to the value of 4 on our x-axis and moving 2 units up on our y-axis. And from here, I'm going to draw a line to connect the dots to show the linear equation. Today's TEK is 8.5b. Our lesson target is that scholars will represent linear non-proportional situations with equations in the form of y is equal to mx plus b. And our DOL is given 4 problems. Scholars will represent linear non-proportional situations with 100% accuracy. Some academic vocabulary words for today are linear equation, slope-intercept form of an equation, which both refer to the equation y is equal to mx plus b. Our y-intercept is our b, and our rate of change is our m. And x and y are our variables. Our variables represent numbers, and they can be any letter. So some operational keywords to go over is that when you see the words twice, of, doubled, tripled, quadrupled, you're multiplying. So twice and doubled mean that you're multiplying by 2, tripled means you're multiplying by 3, quadruples means you're multiplying by 4. When you see the words losing and less than, you are subtracting. And of course, when you see the word more than, you're adding. And here's an anchor chart that has other keywords that indicate different math operations. And then students had to write the equation for 5 more than the product of x and 4. And so for this first IG problem, it reads, the length of a rectangle is 5 inches more than 1/4 the width. So 5 inches more than tells me that we're adding 5. For 1/4, I'm going to write the fraction 1/4. And it says 1/4 the width, which is represented by the variable w. So I know that I'm multiplying 1/4 by w. And then if I combine the information, I have 5 plus 1/4 4th W. And when I look at my answer choices, the correct answer choice was B. For this we do, it says Melinda has $6 more than 3 times as much money as her brother Lester. Which equation represents the relationship between Melinda's money, M, and Lester's money, L? So in this case, we want to figure out Melinda's money. So our equation is going to be M is equal to. So that means that we can cross out answer choice D because that's the only one that has L is equal to. So we have M is equal to, Melinda has $6 more than. $6 more than tells us that we're adding 6. And then it says 3 times. So 3 times is telling us we're multiplying by 3 as much money as her brother Lester. And so multiplying 3 and how much ever money Lester has, so it becomes 3 times L, which in math we can just write 3L. And so if we combine this information, we have 6 plus 3 times L. So we have positive 6, which we dropped the positive sign here, but it's still positive 6. And we're adding together the positive 3L since we're multiplying the 3 and the L. And so if we look at our answer choices, 6 plus 3L is A. This Ija reads the cash register subtracts $2 for every large drink from a $50 gift card the customer buys. Which equation represents this situation? So subtracts $2, that's minus 2. And it says for every large drink. Every is a key word that tells us that we're either multiplying or dividing. In this case, because we know that we're writing linear equations, we're multiplying. And that means that X, our variable, our independent variable, is going to go behind the negative 2 from a $50 gift card. Having a $50 gift card is positive 50. And so if we combine this information, we have negative 2x plus 50 is equal to y. And if we look at the answer choices, that's answer choice C. So this question right here asks, could the equation y is equal to 50 minus 2x represent this situation? The answer is yes, because they're equivalent, they're equal to each other. So if this problem had just asked write an equation to represent the situation, both of these equations, negative 2x plus 50 is equal to y, as well as y is equal to 50 minus 2x, would be the correct answer. Of course, if it's a multiple choice answer, you have to be able to switch around the numbers just to make sure that you select the correct answer. And we know that this relationship is not proportional because it has a y-intercept. The y-intercept is 50. There's another we do problem and 5 non-proportional equation quiz problems for you to do on Nearpod. And these are just what the problems are. And then there's a collaborate board where you had to answer I discovered, I learned, I still have questions about. And lastly, your 4-question DOL, that's a Google form. If you want the answers to the you-dos and the we-dos, I'm going to include a PowerPoint that has the solutions in the description box. Thank you so much for following along in today's math lesson, and see you in the next math video. Bye.